My kids have been asking me to build a cornhole board for them for a while, so I decided to go ahead and give it a shot. Typical cornhole boards are fairly simple to build, but I wanted to incorporate a few features to simplify the setup, storage, and portability of the boards, so I came up with this design. I added alignment pins so I could latch the two boards together. This should shift the weight of the boards to the pins during transport rather than the latches. I designed the legs to fold away the same as most other cornhole boards, but my design gives more surface area where the legs contact the board while in the open position. Hopefully this will keep the legs from deforming over time. The final feature I wanted to add was a way to measure out the distance for setup, so we wouldn't have to get a tape measure or step off the distance every time. The twine is wound around a spool housed in the boards. To keep from having to turn the lever too many times, I geared it up to where each revolution of the handle spins the spool 4 times. Now I'll go over some of the steps that I took to build this cornhole set. After laying out all the parts on a cut sheet, I moved to the shop and cut all of the parts out. I set up a stop for my miter saw to speed up the cutting of all the framing strips to the correct length. This also helps with accuracy and ensures all like pieces are cut exactly the same. I checked everything against my cut sheet before moving on to ensure I didn't miss cutting any parts out. I printed out full-size templates for all the intricate pieces and glued them to the plywood. This really simplifies cutting the more intricate pieces out. I glue 2 pieces together to stiffen up the legs. The template lets me know where I can put nails without interfering with cutting the parts out. The template also helps find the center mark for all the holes I need to drill. Test fit of the alignment pins. I used the gear generator at woodgears.ca to design my wooden gears, then scaled them down to 2 inches in my 2D CAD program. You'd be surprised how accurate you could cut when you take your time. Even using my junky bandsaw, I was only 0.08 of an inch away from my 2-inch mark. A perfectly centered hole is key to having the gears run properly. There was a lot of trial and error getting the Twine retraction system put together to where everything worked properly. But once I got it figured out, I couldn't resist unwinding and winding the string back over and over again. Now that I have that worked out, back to making the boards. Here I'm finishing up one of the legs. I nail it together because I'm too impatient to wait on the glue to dry. Using a beam compass, I marked and cut a template out that my rotozip and homemade mount could ride in. I was hoping to get an accurate and repeatable 6-inch hole cut. It worked out okay. The first cut was a 1/4 inch deep, and the second went all the way through. Some sanding and a 1/4 inch roundover bit, I was able to get pretty close to the 6-inch mark. Finally, time to mount the Twine retraction system. This is the drive gear. I used a threaded insert and a nut tightened together so it wouldn't spin on the threaded bolt. The next gear is kept from shifting out of place with 2 jam nuts, and the spool just slips in place. The framework for the gears is just screwed together. I wanted to be able to take it apart for maintenance later. I added a plastic drywall anchor to act as a string tensioner. The mount broke off after 2 days of use and I had to beef it up a bit. but the concept worked great. Now a few final steps and some finish and we get to try it out. Thanks for watching, and if you like this video, be sure to subscribe. You never know what's coming up next.
Oh, got it.